Jackie San Joao, and they're going to present the SDKs they're doing here, how they architecture them. We will have questions after that, and then after the question, a very short talk about code bar. So, yeah, welcome them with a big applause.
Hi everyone, my name is Ron. I'm here with my colleague Sakis. First of all, thanks for coming. Today we're going to try to take you through the journey we went in the Londroid team to build some SDKs and expose better services to a third-party company. We structured the presentation that we're going to first talk about the why we're doing this, how we did it, how we achieved it, and what results and lessons we learned with it. And hopefully how can this help you guys if you get a similar task in the future. So just to give first a quick introduction about the background services. So Simon spoke a little bit about it in the beginning, but I'll talk about top services and give you a context for the SDKs we need to build. So video consultation, probably the most known service. So if you use Babylon, you can have video or audio consultations with it after any time you want. You just need to prepare the app. It's 24/7. Chatbot AI, we have an artificial intelligence chatbot. You can interact with it, describe some symptoms and get a diagnosis or some actions that you need to do. Then we have a new feature coming out this month with limited delivery and probably next month to everyone. It's about health check. So this is going to contain everything related to monitoring your health and keeping track of your body and all your health stuff. And then GP at hand, you probably heard about it or seen it on YouTube. It's a partnership we have with the NHS that allows you to basically have access to Babylon services for free if you switch your GP to Babylon. So, but let's get to the why. So it all started with a big company that approached us. They wanted to integrate our services into their product. So we started discussing with this company how we were going to do it. The initial plan, or it started as maybe we should just expose our backend APIs directly to them. We moved away from that for different reasons, and we ended up deciding achieving this by providing them with Android SDKs. So then we agreed on a couple of deadlines. So we had an initial 2-month deadline where we had to actually give to them a couple of SDKs with some APIs implemented for them to start integrating and getting the feel of how it's going to be to work with us and vice versa. Then we went through a 5-month stage where they were integrating and we were building new stuff in parallel, followed by a 3-month QA phase. Then this involved both our internal QA teams and also our partner QA teams. We're currently at this stage, close to the end, and we're also releasing this to the public. So let's start with the planning. So on an initial stage, all the team was involved. We had several meetings and presentation amongst the team to decide how we're going to tackle this problem, how we're going to move our code base to actually accomplish this. So one of the things that we realized pretty soon was we probably can split this in many parallel streams, so different SDKs. So we decided to split the team into SDK teams. Normally we had 2 developers per SDK. This was the case most of the times, and at most we had 4 teams working in parallel. This during the first 2 months that I mentioned. Then this evolved a little bit. So how many SDKs? As you guessed, it's more than one. So at least we have the 4 ones that represent the main services that I mentioned before: appointments, monitor that relates to health check, NHS and AI chatbot, but this is not all we have. So in total we have like 12 SDKs, some more supporting SDKs and some others that relate to features that are not as prominent in the app. So one thing that we decided to do, so we decided to follow a bit of the approach that Google did with Google Play services, so you can either integrate one SDK or many. And we also created this wrapper around, so if you want to integrate all the SDKs, you only need actually one line in your Gradle file, and you manage all the dependencies together. So I'm going to give to Sakis to explain a little bit about how our code looks like in a bit more detail. Hello.
So the first step that we did was to have a look at our code base. Our code base has been around for a few years now, and we had different architectures in there. So we had some stuff that we don't really want to talk about. We had the legacy code where everything was inside that was written in the views. We had some code with MVP, model view presenter, and then we had the newest stuff, the MVP following clean architecture. But let's have a look at the clean architecture layers. So we have the views, the presenters, the interactors, the repositories, we can call them gateways, and then the retrofit services. And the next step was to decide which part of these layers we would ship in the SDKs. The first thought that came to our mind, and that was actually a suggestion from our partner, was, hey, how about we ship everything, right? It would be very convenient for them to integrate, they wouldn't need to do anything. But that has some drawbacks. A, we will be enforcing our UX, the popular UX and UI into the SDK, so all the consumers of this SDK would need to follow this UX and UI. And B, we would have extra maintenance costs because of these customizable view layers that would ship as part of the SDKs. So after excluding these view layers from the SDKs, after deciding not to ship those, the next best thing was to, well, we don't ship the presenters because that's very important to the views, so we ship the whole domain layer. So interactors, the posters, the networkings, the retrofit services. So let's have a look at how the legacy code that we have, what kind of changes we needed to make to bring it to clean architecture. As I said, we only had the view layers, so we had to create ourselves all the presenters, the interactors, the repositories, and the retrofit services. In some cases, we're using Olay, so we decided to migrate everything to retrofit. So we had to create all these layers for the legacy system. For MVP, we only had to create the interactors and the repositories. And for the code that was already using clean architecture, we didn't need to create any of these layers. We already had them, right? So it was quite convenient. But for all these three categories of code, we had to move stuff around a bit. We had to move into separate Gradle modules to be able to ship these SDKs. So this is a very simplistic view of the Gradle modules in our application. We had the application module, the interactors, the repositories, and the entities. And let's have a look at how we move them around. So the application module stayed the same. It's not really related to the SDKs. For the interactors, we ended up splitting it in a couple of ways. So A, we had some interactors that we didn't want to expose as part of the SDKs, so they got moved into a separate Gradle module, the one you see here as non-SDK interactors. And then the remaining interactors, we ended up grouping them by functionality, and essentially each of these groups became a separate SDK. For the repositories, we did something very similar. But this time we only split it in two ways: the repositories that we expose in the SDKs, and the repositories that we don't expose in the SDKs. And finally, for the entities, we kept the whole Gradle module as one. We didn't split it up. So let's have a look at an example of one SDK that we shipped. It kind of looked like this. Some interactors, all the gateways and all the entities. And for another SDK, you have again some other interactors, all the gateways and all the entities. And as you can see, what we ended up doing was that with each SDK, we ended up shipping all the gateways and all the entities. And that's not the best approach out there, because why? Because you're shipping too many things, right? For if our partners only consume one SDK, they would be including all these gateways, even for functionality that they don't need as part of the SDKs. So we did this initially, but we're planning to split it up a bit more so that it kind of looks like this. We'll be splitting the gateways in the same fashion as we did with the SDKs. We'll be grouping them by functionality, and then each SDK can have a dependency only on the gateways that it really requires.
Yeah, so let's look at some code. So this is a very basic example of an interactor. So we have to do something interactor, then we're injecting the gateway via the constructor, and then we have an execute function that does what it says, executes the function of the interactor. We pass a request object where we put some parameters that are needed to perform the action, and we actually use the callback mechanism that is quite verbose, and return disposable instead of returning observable or signal. There were two main reasons behind this. One, we didn't want to expose too much RX Java to our partner because we were not sure they were using it that much. And two, this way we could actually enforce our partner to implement all the callback methods or all the outputs that each interactor has as a result. So those were the two reasons to return a disposable instead of observable or single. So we start from the bottom. We have a very simple result class example, just a couple of fields, then a request object, the same thing. And then on the top we have this callback mechanism that I mentioned. This one is quite simple, one on success, one on error. Initially, this felt like a good solution because of the two reasons that I mentioned before, and because this was verbose but it was contained. Later we realized probably this was not the best approach, so we started having or handling error cases differently, so authentication errors differently than network errors, for example. And even success cases, we had more than one callback for each. So some interactors started having 5, 6, 7 callback methods, and as you can imagine, our presenter code became a bit of a callback hell sometimes. So maybe it wasn't the best decision. I think one of the plans for the future is not to get rid of this, but it's making another version of the SDK actual returning observables and singles, and then our partners can choose which mechanism they're going to use. So, but let's go back to the previous piece of code on the interactor. So there's a couple of issues here. So this is named do something interactor, but if we expose it like this for our partner, how are they going to find it? We have, I don't know, around 70 interactors in total. There's a lot. Then we're also injecting the gateway in the constructor. They don't know about the gateway, so they cannot do it as well. And third, even if we could do it, if we expose it like this, we would be exposing the implementation and architecture details from our partner, and we don't want that. So the solution we found out, so we basically created some sort of wrapper that injects all the interactor dependencies and allows to call the all the interactors and get a result using the callback mechanism. So if you look at this simple example, so we have this clinical records API class and this clinical records SDK class. So each SDK has these two classes, one representing the API, another one representing the SDK itself. So you can get an instance of the API class using that static method from that SDK class, and then you can use it. You call do something, and this is going to call do something interactor, so it's mapping to that, again passing the request and a callback. So, but maybe let's use a diagram to see how this works. So we have a client that requests an instance of the API using that method above to the clinical records SDK. By the way, this box clinical records SDK mentioned refers to that class above and not to the SDK itself. Then the SDK class instantiates the API, returns it to the client, and then the client has access to all the interactors via the API. And then, as Sakis mentioned before, all the entities in the gateways are shared, so the client has everything they need to perform any needed action. So, but let's look at some real examples. So this example is an SDK API interface that we have. This one specifically is for the appointments SDK. As you can see, we're returning a disposable. We have get appointments request object and a get appointments output. So our callback mechanism, we named them outputs, and the name came from output boundaries. Also, there's a lot of Javadoc here, so we added Javadoc for every code that touches SDK. So that's this. Then we have one example as well of one of our presenters using the SDK. We can see on the fourth line, Babylon Appointments API. .getAppointments. We pass a request object that is created above. This one is quite simple. It takes the type of appointment upcoming and the patient ID, and then one example of one of the compact methods from getAppointments output. So this is us using the SDK in our app, and this is a decision that we took from day one and was quite important. We wanted to dog food all the SDKs ourselves. If you don't know what dog fooding is, it's basically a company consuming their own products. In our case, we're consuming the SDKs. We could do it just for testing. We actually do it for production as well. So the Babylon app that you can get from the Play Store is already using the SDKs we built. So the rule that we wanted was we want to use the SDKs inside the app exactly the same way as our partner is using them. So there's two things for this. One, we needed to inject these SDK classes or these SDKs APIs in our presenters or where we need to use them, rather than the interactors directly, and we do that. And the other point, we actually wanted to build our app using the SDKs as a dependency from Artifactory, so in the way we actually push them. There's an exception here for local development. We actually use local Gradle module dependencies, and this allows us basically to make changes to both the SDK and the app at the same time in one single PR or one single branch, rather than having to go through that complicated process that would probably slow us down a bit. And because, again, we did this in parallel, this helped a lot. But when it gets to CI, our Jenkins builds actually publish first, build and deploy all the SDKs to Artifactory, and then when the Babylon app is is built, he actually uses the SDKs or consumes the SDK dependencies from Artifactory directly. So every APK we push, we deploy to Hockey app or to our alpha or beta channels and release as well. It's built exactly the same way as our partner app is built. So all the QA process and everything around it, it's tested, dog fooding to the max, from testing to production, everything. So if we go a little bit more in detail about the build and deploy. So this started as a slow and manual process where we had a local Maven repository where we declared all the dependencies for the SDKs. Initially, the partner actually had to copy this, paste it in their project, and then consume the dependencies from there. This was a bit of a slow process to get a release out, so we decided to automate it a little bit. So we started pushing the SDKs to Artifactory, but even at this stage, we had 3 tasks per SDK, so one to build the SDK, one to build all the Java doc, and another one to deploy to Artifactory. So we had 36 tasks in total. So it was better than before, but it was still a bit manual and a bit slow. So we continued automating it, and at the moment we have one single Gradle task that builds all the SDKs and all Java doc and deploys everything to Artifactory. So to give you a bit of a context, making a release of the SDKs initially took around a day. Then it moved to around an hour, and now it literally takes a minute to run this Gradle task. And some stats around it. So these 9-10 months we released around 25 versions of the SDK. This excludes what fixes, otherwise it would be maybe 100. I'm joking. Just an extra 4 or 5 maybe. And yeah, this gives one release around every 10 days, so it's been a busy 10 months since the project started. I'm going to hand over to Sakis to talk a little bit about security and how we handle it here.
So, in Babylon we take security really seriously, unlike this picture, I guess. So the most important thing that we do is that we don't store any sensitive basic information in the device. If there is anything important that we need to save, we encrypt it with the Android key store, and then we store it. Another thing that we do is that we use TextCard. TextCard is the big brother of Program. It's a commercial tool, and it provides some extra features like control flow obfuscation, encryption of classes, and further optimizations. Another thing that we wanted to do from the get-go was to make sure that nothing will get locked in production, but at the same time that we would have locking enabled for all the other environments that the SDK could point to. So for non-production environments, we would enable logging, and then our partners were able to debug issues and provide us with the logs to be able to have a look ourselves and fix all these issues. But for production, everything was disabled. So there was this mapping from testing and non-production environments, logging was disabled, and for production, sorry, the other way around. For non-production environments, logging was enabled, and for production, everything was disabled. An interesting fact was that we had to create a small wrapper around Timber, as we're using Timber to log. We needed this wrapper to make sure that even if the application that is consuming the SDKs initializes Timber, that we still don't log anything in production, that Timber is disabled for as far as the SDKs are concerned. Another interesting thing that we wanted to do was to uniquely identify these consumers of the SDKs and allow or restrict access. And we ended up doing that using the application public certificate hash. So what happened, this happened in 2 stages. So at the development phase, we would ask the hash of the public certificate of the application of our partner, and then we would take that and we would append it to the application ID, and we would create a new hash, and we would store that hash inside the SDKs. And then at runtime, we would essentially do something very similar. We would calculate the same hash, and if this hash matched against the pre-computed value, then we would allow access. If it didn't, we would restrict access. And that was quite helpful for us. And it allowed us, as I said, to uniquely identify these consumers of the SDKs and to be able to enable or disable specific features for them. So an example of that is that the same SDK was providing, that the Babylon application was consuming, was providing access to production, but at the same time it wasn't providing the production environment to our partners because they were only just starting to integrate, so they didn't actually need access to production. Moving on to another topic. Our SDKs, for the biggest part, they didn't contain any views, as I said. There were some cases where we were using some third-party libraries that were using activities themselves to perform an action via the start activity for result mechanism. So as we didn't want to expose directly these third-party libraries, we ended up wrapping them with our own activities, providing a similar mechanism to performing this action and then returning the result. Moving on, Kotlin. Initially, the SDKs, we started writing them in Java. We only thought about moving to Kotlin around November, a few months after the process with the SDK started. We decided we were very happy to bring Kotlin on board because it's a cool language, right? And we did the same with SDKs. We started using it inside the SDKs, and we didn't have any issues with it whatsoever. The only point I want to make is that in some cases, the interactor request objects that we had in Java, they were using auto-value and builders, but as some of them were rather large, we decided not to move them to Kotlin data classes, as that would mean that using them from Java that our partner was using would be a bit annoying because you end up with a massive constructor. On the SDK size, right from the get-go, we want to make sure that the size of the SDK and the dependencies that we use are as few as possible, and you should do that as when creating an SDK or a library, because you are essentially forcing all these dependencies to the consumers of these SDKs. So we went through the process of going through all the dependencies, making sure that everything made sense, we didn't have anything extra, and in some cases that meant that we moved some dependencies from the SDK Gradle modules to the application module. An example for that would be our mixed panel analytic library that wasn't necessary to be inside the SDKs, so we moved it to the application Gradle module. On native libraries, we had quite a bit of fun with those. We were using a couple of third-party libraries that included native libraries, but as we had quite strict size requirements from our partner, we wanted to find a mechanism to essentially get rid of them. So, as you know, native libraries are rather large, and in some cases, you need multiple of them, one per architecture, right? So we had, I'll give you 2 examples. So in one example, we contacted this third-party library, and we asked them to provide us with a more lightweight version of the library that didn't contain these native libraries, as we didn't really use this functionality from the native libraries, and they happily did that, so we integrated the lightweight version of the third-party library. But and on the second scenario, we had for our video consultation, we're using a library that contains some native libraries again, and we needed the functionality from these native libraries. So what we ended up doing was to load these native libraries at runtime. So we requested them to give us with a slightly customized build from their third-party library that allowed the loading of these native libraries at runtime from a custom path. And the artifact that they gave us didn't contain the native libraries. So we ended up hosting ourselves the native libraries on an S3 bucket on Amazon. And then at runtime, as soon as the SDK initialization happened, we would fetch the correct native library according to the architecture of the phone and then load it. Final point to be made is, as I said, we're using DexCard, and DexCard tends to reduce the size of the SDK a bit, and also the method count, as it does the obfuscation and removing the unneeded code and does some optimizations. But let's move back to Shao.
Yeah, so going back, going forward to the end of the house, I'm going to try to explain a little bit about the documentation part. We have to be involved as well. So Java doc, you saw an example on those pieces of code I showed before. We had this enforced with check style static analysis. So every piece of code or every piece of PR that touched the SDK code would not build on Jenkins if Java doc was missing for those files. This was a very important decision we made. Release notes for the SDKs. It also started as a very manual and painful process. Initially, we were literally going through every commit message manually in between releases and trying to come up with some release notes from those commit messages that sometimes are quite funny. So this, as you can imagine, took a little while. We're yet to find a way to automate this. Right now we're using the GitHub code owners feature. So Sakis, as the project owner, basically owns every piece of code of the SDK. So if a pull request has some SDK code that doesn't contain the release notes are not updated on the same PR, Sakis goes and punches that person. So yeah, it's not automated, but it works out well because everyone is afraid of you. So. Sample app, we built a sample app. We have several examples of using most of the SDKs and a lot of APIs. This allows our partner as well to try stuff and to reproduce some bugs in there that helped us sometime during the way. And we also created some wiki pages on the same repository as the sample app and the release notes, where we have documentation for all the SDKs and how to use them. Then support was a big part. This is a big partner. There was more than one team involved from their side. So we had a dedicated Slack channel. As you can imagine, this was super time consuming. A lot of people were involved, and we wasted a lot of time here addressing requests and addressing issues. Soon we created a dedicated Jira board. It might seem like process and not necessary, but when you're just dealing with Slack emails and daily and weekly calls, trust me, you will want a Jira board or something similar to keep track of everything. It helps a lot. And that took us to the finish line. So a few things that we took from this project: improve code quality. Just because we have much less legacy code, as you saw, we moved away from a lot of legacy and just MVP to clean architecture. That alone improved a lot. Then we went to several QA stages that helped us a lot, fixing a lot of stuff, even in our app. The conclusion we can take from this, and we took as a team, is that it helped us a lot. It made our life much easier, as you saw before from the diagram Sakis showed. For clean code, we literally just have to move some models around and fix a couple of things. I think the bulk of the time we spent during these 10 months was probably on the initial stage, moving some of that legacy code to clean. Then everything was much easier after that. And then on green, we also have a little bit of a new secret architecture that we're working on in the team at the moment. The plan is maybe to release a couple of libraries and a sample app around that as well as open source. You can come and talk to us after the talk and we can explain you a little bit more about it. So lessons learned, planning. Two examples. One, the automation of the build process. We could probably have planned it earlier and made it earlier. That would have saved us some time. The Java doc enforcement, we did it 3 months down the road. So the poor guy that had to merge enabling that check had to go back and write all the Java doc. So you can take 2 lessons from here, do it from day 1. If you don't, pick someone else in the team to do it. Otherwise you're screwed. Don't create silos, merge often. We did create some silos on those first 2 months, those first 2 month deadline that I mentioned. We ended up with a lot of conflicts where we merged to develop, but worse than that, we actually blocked our releases for around 2 months because we introduced a lot of small issues in the app and we basically were stabilizing develop for a long time. So don't do it. Start merging often into development, keep everything tested. More logging, Saki's mentioned a little bit. The more logging, the best. Our partner came with a lot of issues that were hard to track, and maybe if we had a little bit more logging, would make it easier to track the bugs and find out what it actually was. So maybe we could have done more. And then version control documentation, I mentioned wiki pages. Don't do it, just use some readme files. It's marked down anyway, link through them, and you'll have a history on your documentation together with matching your code changes. We don't have it. I mean, it's good, but it could have been better if we had the history matching the code. So the biggest lesson is don't panic. There's gonna lots of problems are going to happen. We had several. We had difficult tasks. You think you're not going to do it, but you will. You can spend like 30 seconds running around the office like that. It's basically what me and Sakis did 1 hour ago when we realized this was happening. So, but yeah, then you can sit down and you go through it. We're software engineers. This is our life every day. Tasks that we think are not possible, and then we just bang our head against the wall and it comes out. So don't panic. You'll do it. And I think that's all we have, so thanks for coming. You can follow me and Sakis on Say Hi on Twitter or Medium. And Simon mentioned we're hiring, you can come and talk to us if you want to know more. And now some questions if you have.
Questions?
No? Okay.
How often do you release?
Initially you included all gateways in your SDK. Was actually using the, sorry, not Crowbar, the DexGuard, still able to get the SDK that signs down for you?
No, because it would be a separate module. So the DexGuard operates on a specific Gradle module. It doesn't operate on all SDK. So the gateways are deployed as a separate artifact on Artifactory, so that all the SDKs depend on. So there isn't that link that the particular SDK and the gateways get somehow built together so that DexGuard knows how to remove all the unneeded code. So no, that doesn't happen. And one of the reasons that we ended up shipping our first version with this was that our partner was consuming all the SDKs. So in the end, for them, it was the same, or whatever the approach we do. But moving forward, as we're going to have multiple partnerships in the future, then it will be more important.
There's an open question around how do you manage your code? Is it monorepo? Is it sub-modules? In your case, you mentioned you have about 25 modules. What's your take on that? And what about version control of your SDKs?
So yeah, it's monorepo. When we started with the project, we thought maybe we should split it in separate repositories, but developers are lazy, so we postponed the decision. and then we were like, okay, maybe we should create one repository for all the SDKs and one for the public application, things like that. But we proved that we're even more lazy. We put everything in, and that was a good decision in the end. It would be a lot of work to manage separate repositories. You would have, for local development, you would have probably Git submodules then, and it would be a pain to manage that.
We just have the sample app and all the documentation in a separate repository, but all the SDKs together with the development.
So, when you are versioning the SDK, how do you force your clients? Like, I don't know how many clients you have that are already using your SDK. How do you force them to use the latest SDK version?
At the moment, we have just one partner. That's how it all started. But the idea is to have more partners around it. So basically, every time we ship. We're still not in version 1.0, so we're updating all the time. So and because we. Can you explain something?
So they can stay in an old version if they like, and they will have support for that for our initial partnership for 6 months. But they cannot stay. They're free to stay in that version for as long as they like. But at some point we will stop supporting it. So they would need to move to a newer version. Does that answer your question?
Yeah, kind of a small little. How do you sync with? I guess you haven't did this problem yet, but how do you sync your SDK release with the server release? Because I guess your servers are also creating new versions of the endpoint.
We haven't had that yet because we don't release versions of our backend endpoints that often. But that would be something that we will start to think about, I guess. I guess it comes down to the period where we provide support for a particular SDK. So if we release an SDK, then this version, the version that it speaks to in the backend, that needs to be there. That needs to be supported for the next 6 months or so.
Fair enough. Thanks.
All right. And here. All questions? On the other side. Yeah.
Yep. Thank you for the talk. So sorry if I asked the question on the last guys, but it's apparently very small question for you guys. So for your local version, that's basically has a local all the SDKs has local modules. Switching from 7 to 25 modules, how has that affected your build times? Again, for the local builds.
So it has improved a bit. The thing is that you have annotation processing that happens that is not incremental yet. I think that this is going to ship in the next or the version of Gradle after that. So after that happens, we should see some dramatical results improving the performance. At the moment, we're seeing a slight optimization, but not much.
Lovely, thank you.